Hello students, today we would like to discuss about density of states topic. Density of state is nothing but the number of available energy states per unit volume. I repeat, number of available energy states per unit volume called as density of states. Now, to find the number of energy levels in a cubical metal piece, and to find number of electrons that can be filled in a given energy level, we would like to construct a sphere of radius n in space. Then the sphere is further divided into many shells, and each of these shells represents a particular combination of quantum numbers, namely nx, ny, and nz. The diagram, we have two shells where the first shell radius n and the corresponding energy E, and the second shell radius n plus del n and the corresponding energy E plus dE. Let us consider two energy values E and E plus dE. The number of energy states between E and E plus dE can be found by determining the number of energy states between the shell of radius n and n plus del n from the origin. The number of energy states within the sphere of radius n equal to 4 by 3 pi n cube. Okay, so you, all of them are known very well about the so sphere volume of the sphere. So the number of energy states within the sphere of radius will be equal to how much? N is equal to 4 by 3 pi n cube. Okay, since nx, ny and nz will have only positive values, so we have to take only one octant of the sphere, that is 1 by 8 of the sphere volume. As we know that the principal quantum number nx, ny and nz should have only what? Positive value, no negative values. Okay, so the principal quantum number nx, ny and nz will be positive only at the octant of the sphere. So nx, ny and nz will be positive in the octant only. So the formula will be modified as n equal to 1 by 8 into 4 by 3 pi n cube. Okay. Next, the number of available energy states within the sphere of radius n equal to 1 by 8 into 4 by 3 pi n cube we discussed. Similarly, the number of available energy states within the sphere of radius n plus dn will be equal to 1 by 8 into 4 by 3 pi n plus dn whole cube. The number of available energy states between the shell of radius n and n plus dn, or we can say that between the energy levels, that is E and E plus dE, will be equal to 1 by 8. The 1 by 8 is a common term for both the equations, both the above mentioned equations. So E and E plus dE will be equal to 1 by 8 into 4 by 3 pi n plus dn whole cube minus 4 by 3 pi into n cube. So in order to calculate the energy difference between the two levels, okay, we are subtracting n plus dn minus n. Okay, in terms of energy, we can write that equation E and E plus dE will be equal to 1 by 8 into 4 by 3 pi n plus dn whole cube minus 4 by 3 pi into n cube. So the number of available energy states between the energy interval, that is E and E plus dE, will be represent Z of E into dE, which will be equal to 1 by 8, and the common term, that's one more common term we have, is what? 4 by 3 pi. So Z of E into dE will be equal to 1 by 8 into 4 by 3 into pi into, you like to substitute the formula or apply the formula on n plus dn whole cube. We know that a plus b whole cube, which will be equal to a cube plus b cube plus 3a square into b plus 3 into ab square. Okay. Now, After using the formula, applying the formula, the equation becomes 1 by 8 into 4 by 3 en cube plus 3n square into dn plus 3dn square into n minus n cube. Okay, so in this equation, plus n cube and minus n cube can be cancelled. Okay, so plus n cube and minus n cube can be cancelled. So after the cancellations, okay, after the cancellations, the power dn square and dn cube you like to ignore, or it will be or neglected. The reason is the value of dn square and dn cubes are what? Very small. Okay, so after ignoring dn square and dn cube, our equation will be z of e into de equal to pi by 6 into 3n square into dn. Further, we can simplify this equation. The denominator 6 in the numerator 3. So we can cancel it. After cancellation, the simplified form is z of e into de equal to pi by 2 into n square into dn. We know the energy of the electron in a cubical metal piece of size, that is E equal to n square h square divided by 8 ml square. During the second lecture, we discussed, okay, the derivation of E equal to n square h square divided by 8 ml square. I hope everyone knows about what E equal to n square h square divided by 8 ml square. The derivation of what? E is equal to n square h square divided by 8 ml square. Okay, so we have E is equal to n square h square divided by 8 ml square. So from that equations, we can calculate the value of n square. Just rearrange this equation. So n square is equal to 8 ml square into E divided by h square. Then we can calculate value of what? N. So n is equal to how much? 8 ml square E divided by h square. We are calculating now n. So it should be what? Power 1 by 2 or square root. So n is equal to 8 ml square into E divided by h square power 1 by 2. Next, now I would like to differentiate the equation number 2. Check the equation number 2 now. What's equation number 2? N square equal to 8 ml square into E divided by h square. Once you differentiate, this equation becomes 2n into dn equal to 8 ml square divided by h square into d. Then we would like to rearrange these equations. Keep the n dn at the left hand sides, take the 2 towards the right hand side, so it becomes a denominator. So n into dn equal to 8 ml square divided by 2h square into de. Now we would like to take equation number 1. What about equation number 1? Z of e into de equal to pi divided by 2 into n square into dn. Now we would like to slightly modify this equation. Okay, it's n square, right? So instead of n square, we can write that n into n. So this equation becomes z of e into de equal to pi divided by 2. Instead of n square, we can write n into n dn we can write. After that, we would like to substitute the equation number 3 and 4 in the above equations. What about equation 3? Equation 3 is the value of n. What about equation number 4? The value of n into dn. Now, the equation 3 and equation 4 will be substituted in the equations. That is z of e into d equal to pi by 2 into n dn. Then after substitution of equation number 3 and 4 in the above mentioned equation, the above equation becomes z of e into de equal to pi by 2 into the value of n is how much? 8 ml square e divided by h square power 1 by 2, and the value of n into dn becomes 8 ml square divided by 2h square into de. Now look at this equation. In this equation, the third term, okay, so divided by 2 is there. Okay, so we can write that this equation is z of e into de equal to pi by 4. We can write in the denominator 2 into 2 becomes what? 4. So we can write that pi divided by 4. The next, the second term and the third term, the common term is which one? 8 ml square divided by h square. Okay, so the common term is which one? 8 ml square 8 ml square divided by h square. After rearranging these equations, the equation becomes z of e into de will be equal to, okay, pi by 4 into 8 ml square by h square is a common term. Check this equation here, power 1 by 2. Okay, in the third term, power 1. So 1 by 2 plus 1 becomes what? 3 by 2. Okay, so 8 ml square divided by h square power 3 by 2. Next, e power 1 by 2. Okay, e is not a common term. So e power 1 by 2 into dE. Okay, next. Okay, so z of e into dE equal to pi by 4, 8 divided by h square. Now I would like to take the L square from the square bracket. Okay, L square power 3 by 2. Once you take it outside of the what? Okay, outside of the what? Square bracket, the equation becomes, that is L becomes what? L cube. So L square power 3 by 2, then it becomes what? 3. Okay, so 6 divided by 2 is how much? 3. So L cube. So L square power 3 by 2 becomes what? L cube. Then e power 1 by 2 into dE. So finally the equation becomes what? Z of e into dE equal to pi by 4 into 8m divided by h square power 3 by 2 into L cube e power 1 by 2 into dE. Here L cube represents the volume of a metal piece. Volume of a metal piece. If L cube is considered equal to 1, then we can rewrite the equation. Okay, so if we rewrite the equation becomes Z of E into dE equal to pi by 4 into 8m divided by h square power 3 by 2. L cube value is how much? 1. Okay, then e power 1 by 2 into dE. That's equation number 5. Okay, so Z of E into dE equal to how much? Pi by 4 into 8m divided by h square power 3 by 2 into e power 1 by 2 into dE. According to the exclusion principle, each energy level provides two electron states, one with spin up and another spin down. Okay, so how many number of spins? 2 spins. So we would like to multiply 2 with the equation number 5. Then the density of states equation becomes Z of E into dE equal to, okay, multiply 2 with the fifth equation, that is 2 into pi by 4 into 8m divided by h square power 3 by 2 into e power 1 by 2 into dE. Then we can simplify this equation. Okay, so 2 divided by 4, so we can cancel it. Okay, so 4 becomes 2 in the denominator. So Z of E into dE equal to pi by 2 into 8m divided by h square power 3 by h square power 3 by 2 into e power 1 by 2 into dE. It means that Z of E into D, that is density of state is directly proportional to the energy. That is Z of E into D is directly proportional to e power 1 by 2. Okay, so once again I would like to repeat. Okay, the density of state is nothing but what? Number of available energy states per unit volume. Okay, now we derive the number of available energy states per unit volume. Per unit volume. Okay, what about the cube unit volume? Okay, V equal to L cube. That is why the value of L cube is equal to 1. Here we have taken. Okay, so hence the final equation becomes Z of E into dE equal to pi by 2 into 8m divided by h square power 3 by 2 into e power 1 by 2 into dE. Okay, so thank you to all of you.